Back when we began to use the chain rule, we played around just a little bit with logarithms. And I wanted to highlight something today because we're going to talk a little bit more about that in terms of natural logs and e, and in calculus you use them a lot. So I want you to remember that if I say like a to the y equals x, that's the same as saying log base a, okay, let's fill it in here, log base a of x is equal to y. And I always get confused about logarithms, so I always write it out. And when we did the chain rule, we did learn that the derivative of a to the x, so if I did something like this, d to the dx of a to the x is equal to a to the x times the natural log of a. I will give you a link in the description for that. And it's fun practice, so I think you're going to want to make sure that you know that. But as long as we agree on the base, then let's look at it in terms of this here, because now we've been doing implicit differentiation, we can have a little bit more fun with it, right? So I could say, I'm going to go back to this a to the y equals x part. I want to use it from there. And we'll try and apply this rule correctly. And just remember the chain rule side of it. So we have a to the y equals x. So I think if I take the derivative with respect to x for this, what I would end up with is more like a to the y ln of a, but also chain rule dy dx, because this is not an x anymore, it's a function of x, so you got to put the dy dx in there. And that's going to equal what? Well, the derivative of x is 1. Right? So if I want dy dx, then I can say that it's 1 over a to the y ln of a, like that. Now, what if I want to use e? Because that's what we're all about, right? So let's say that a is equal to 2.71, whatever e is. Let's say it's e instead of a. Well, that would be, of course, 1 over e to the y ln of e. But you know what? The natural log of e is equal to 1. So it'd just be 1 over e to the y, like that. And so whenever you're doing natural logs, this is important to remember because it means that the derivative of the natural log of x is equal to 1 over x. You see? Because what the original was right there. So this is going to be very valuable to us. This is kind of, I'm not going to call it a proof, but it's kind of a demonstration of where the logic is here. We're going to be doing logarithms. Whenever you need to take the derivative of natural log, it's 1 over x. And you could just remember that, but it's good to see where it came from.